This video is going to present concepts that are used to write equations of lines. While you're watching the video, be sure to complete the example problems on the provided handout. Be sure to take the opportunity to watch the video or parts of the video more than once if you need to. Remember that we will take time in class to discuss any questions you may have and practice using the concepts. While writing equations of lines, we're going to be using a number of different formulas. If we're given a slope and a y-intercept, we're going to be using slope-intercept form. Slope-intercept form takes on the form y is equal to mx plus b. If we're given a slope and a point, we're going to use something that's called point-slope form. Point-slope form will be y minus some y coordinate is equal to the slope times x minus some x coordinate. And if we're given 2 points and asked to write the equation of the line that connects those 2 points, it'll be a two-step process. We'll be finding the slope, m being equal to the difference in the y coordinates over the difference in the x coordinates, rise over run. And then after we find that slope, we'll go ahead and plug that into point-slope form. Y minus the y1, y minus some y coordinate, equal to the slope times x minus the x coordinate. In these next two examples, we're going to be asked to write an equation of the line that has the given slope and y-intercept. Because we're going to be given slope and y-intercept, we're going to be using that form. Y is equal to mx plus b. mx plus b is called slope-intercept because when you take a look at the name, you can immediately identify the slope, you can immediately identify the y-intercept. If we're given that our slope is equal to 3 and our y-intercept is equal to 4, we're going to use that formula and plug right in and say our line is y is equal to our slope 3 times our independent variable x plus our y-intercept 4. If we're given that our slope is equal to 2/3 and our y-intercept is equal to -4, again we're going to plug into slope-intercept form and our line will have the name y is equal to our slope being equal to 2/3 times our independent variable x, and our y-intercept is -4 plus -4. I'm going to write that as -4. In this example, we're going to write an equation of the line given the slope and a point. And because we're given a slope and a point, we're going to use something called point-slope form. Point-slope form takes on the format y minus my y coordinate equal to slope m times the quantity x minus my x coordinate. In my example, they're giving me a slope that's equal to -3. I'm going to be plugging that in for m, and they're giving me this ordered pair 3, -1. The x coordinate is 3, and so I'm going to plug 3 in for x sub 1, and my y coordinate is -1. I'm going to be plugging that in for y sub 1. And so the formula will read y minus the -1, I'm going to call that y plus 1, equal to my slope is equal to -3. I'm going to open up that set of parentheses and then say x minus my x coordinate, x minus 3. This is point-slope form, and typically we don't leave lines written in point-slope form. It's a good equation, but oftentimes you'll see these things simplified into slope-intercept form. So let's go ahead, let's put it into slope-intercept form. I'm going to make it look like y is equal to mx plus b. I'm going to start out by distributing my -3. So the equation will become y plus 1 is equal to, I'm going to take that negative 3 and distribute over the parentheses. It'll be 3 times that x, negative 3 times that x, and negative 3 times that negative 3. And so I'll say negative 3 times my x, negative 3 times the negative 3 will become plus 9. All right, I want this to be a y equals equation to be in slope-intercept form. So I'm going to be subtracting 1 from both sides. Subtract 1 from the left side and then subtract 1 from the right side. And when I do that, I'll have an equation y equal to negative 3x, and 9 minus 1 will leave me with 8. So this is my line in point-slope form, and this is my line in slope-intercept form. In this example, they're asking me to write an equation of a line that passes through 2 points. We're looking at the point negative 2 comma negative 3 and 2 comma negative 1. To write an equation of a line, I need 2 things. I definitely need a slope and I need a point. I have 2 points. I don't have a slope, but I have the opportunity to find the slope using slope formula. So I'm going to say my slope m is equal to, it will be the difference in the y-coordinates over the difference in the x-coordinates, rise over run. So negative 3 minus that minus 1, I'm going to write that as plus 1, over negative 2 minus 2. When I go ahead and simplify this, negative 3 plus 1 is negative 2. And negative 2 minus 2 is negative 4. And so when I reduce that, my slope is equal to a positive 1/2. Now that I know my slope is equal to a positive 1/2, I have a slope and I have a point, and I can use point-slope form. It doesn't make any difference which point I choose. Either of the points will suffice. And so I'm going to use the point 2 comma negative 1 and the slope 1/2. I'm going to be using point-slope form, and so I'll say y minus my y-coordinate minus my minus 1, so plus 1, is equal to my slope 1/2 times x minus my x-coordinate 2. Again, typically I don't see these left in point-slope form, so I'm going to move into intercept form, and when I move into intercept form, it will become y plus 1 equal to, I'm going to distribute the 1/2 over the x minus 2, and so 1/2 times x, 1/2 times x, and 1/2 times that negative 2. 1/2 times negative 2 is going to give me minus 1. I'm going to subtract 1 from both sides of the equation, subtract 1 from here and subtract 1 from here, and I'm going to end up with y being equal to 1/2 x minus 2. I could have gone up and used the other point. I could have used negative 2, negative 3, and the slope 1/2, and would have gotten the exact same equation. So let's go ahead, let's do that and show that it really works. If I take a look at y minus my y-coordinate minus my minus 3, so plus 3, equal to my slope 1/2, and then x minus my x-coordinate, so x minus my minus 2, so x plus 2. There it is in point-slope form. I'm going to distribute the 1/2 inside, and so y plus 3 equal to 1/2 times x, 1/2 times 2 is going to give me plus 1. And now I'm going to say, let's go ahead, let's subtract 3 from both sides of the equal sign. And in subtracting 3, I have y is equal to 1/2 x, and 1 minus 3 is going to give me minus 2. I'm being asked to write an equation of a line that passes through the point -3, -5, and is parallel to the line y is equal to -4x plus 1. I know that parallel lines have slopes that are the same. They have the same rise over run, and so I know that my parallel line will also have a slope that's equal to -4. So using m being equal to -4, I'm going to go ahead and write the equation of my line using point-slope form, and I'll say y minus my y-coordinate minus that minus 5 is plus 5. It's equal to -4 times the quantity x minus my minus 3, so plus 3. I'm going to distribute the 4 inside of the parentheses, and when I do, it will become y plus 5 equal to -4x. -4 times positive 3 is a minus 12. And then I'm going to go ahead and say, let's subtract 5 from both sides of this equation. And so it will become y is equal to -4x. -12 minus 5 will give me a minus 17. The line y is equal to -4x minus 17 is parallel to the line y is equal to -4x plus 1. Now I'm going to be asked to write an equation of a line that passes through the point -1, 2. This time, though, the line is going to be perpendicular to my line y is equal to 3x minus 4. Perpendicular lines have negative reciprocal slopes. So if the slope of this line is equal to 3, then the slope, of my line that is perpendicular to this line, my perpendicular slope, will be equal to -1/3. What I do is I actually flip the ratio, right? 3/1 becomes 1/3, and I take the opposite sign. So since this one's positive, I'm going to use a negative. My perpendicular line has a slope that's equal to -1/3, and now that I have the slope and I have the point, I'm going to put it together using point-slope form. So I'll say y minus my y-coordinate, y minus 2, it is equal to my slope, -1/3, times x minus my x-coordinate, x minus that minus 1 will become x plus 1. I'm going to distribute the -1/3 inside of the parentheses so that I can move out of point-slope form into intercept form. And y minus 2 is equal to -1/3 times x gives me -1/3 x. And the -1/3 times the positive 1 gives me -1/3. I want to go ahead and add 2 to both sides. Because I'm going to add 2 to both sides, I'm going to have to do it in the form of a fraction and with a common denominator using the 1/3. So this will become y is equal to -1/3 x minus 1/3 plus, and instead of writing that as 2, I'm going to write it as 6/3. And then finally I'm going to complete that addition, and I'm going to say y it's equal to -1/3 x, and a -1/3 and a positive 6/3 will give me plus 5/3. My line that is perpendicular to y is equal to 3x minus 4 and moves through the ordered pair -1, 2 is going to be y is equal to -1/3 x plus 5/3. We're going to write a model using linear equations. It says that we have a rectangular plot measuring 16 feet by 25 feet in a community garden. So probably one of the best things we can do when we solve these kinds of problems is to make sure that we draw ourselves a picture and label any of the quantities that we can. My garden is 16 feet by 25 feet. Then it says I want to grow tomato plants that each need 8 square feet of space and pepper plants that each need 5 square feet of space. They would like me to write an equation that models how many tomato plants and how many pepper plants we can grow. So we're going to set up our variables, and I'm going to say, let's let x be equal to the number of tomato plants, and then let's let y be equal to the number of pepper plants. Since each tomato plant requires 8 square feet, the amount of space I'm going to need for tomato plants would be 8 times the number of tomatoes, right? And so 8 times x. And since each pepper plant requires 5 square feet, the amount of space I need for pepper plants will be 5y. And if I add those two areas together, that's how much area I need for my community garden filled with tomato plants and pepper plants. So I need to find out how much space I have available to me in my community garden. I'm going to remember that area is equal to length times width. And so my area is going to be equal to 25 feet times 16 feet. My area will be equal to 400 square feet. All right, so that means 8x plus 5y needs to be equal to 400. My model, 8x plus 5y, is equal to 400. Now they're asking me to actually use the model. They want to know how many pepper plants can we grow if we grow 15 tomato plants. And so I'm going to say, let's let there be 15 tomato plants. I'm going to let x be equal to 15. And so it will become 8 times 15 plus 5y is equal to 400. And 8 times 15, 120, plus 5y is equal to 400. I'm going to say let's go ahead and let's subtract 120 from each side. When I subtract 120 from each side, I'm going to have 5y sitting by itself. And over on the other side, 400 subtract 120 is going to go ahead and give me 280. I want to know what y is, and so I'm now going to divide both sides of this equal sign by 5, and y is going to be equal to, and 5 goes into 280 56 times. I'm going to be able to plant 56 pepper plants if I plant 15 tomato plants. I hope that the video was informative. Remember that you may watch this video as many times as you like to ensure that you understand the concepts that have been presented. We'll work on problems in class that will allow you to practice using these concepts. We'll have the opportunity to discuss any questions that you still have. Thank you very much.